Okay, so I'm going to work my way through the exam papers now on questions that people found difficult. So this is 2019, the experiment question 2, and this is mostly for Kate and Megan. So firstly, you're asked magnesium into ethanoic acid. So that's a reaction with an acid and a metal, so bubbling, fizzing, and you'd also see a white powder. The formula then for both the products, so what I have is I have CH3COOH plus Mg. Okay, and anytime an acid and a metal react, we produce hydrogen, which is H2. Okay, and what actually happens is that this Mg takes the place of the H here, so it'll be CH3COO. Now, this is 1 minus charge, okay, and this is in group 2, so its valency is +2. So I need 2 of these in order to make this correct. So the 2 products are CH3COO2 Mg and H2. Okay, if I was to balance this correctly, I'd have to have a 2 there. Okay, but you're only asked for the products, so answer 1 and answer 2. Next then we're asked to show a chemical test for ethanol. Okay, so we pretty much have 3 tests. Okay, the first one that we have is adding Tollens reagent. Okay, the second one then that we have is adding Fehling's. Okay, and you could also do your adding of potassium permanganate, but we're not going to do that now. So with the Tollens reagent, we're going to use, and the chemicals you need, and you need to know these, is silver nitrate. Okay, so you add silver nitrate. Okay, that is your Tollens reagent. You then have to say you heat it. Okay, and we end up then with the silver mirror or precipitate on our test tube, and we did that experiment, so that's your silver precipitate. Next, here we add Fehling's. Okay, and Fehling's, remember, is Fehling's 1 and Fehling's 2. Again, we heat, and this time what we see is a brick red precipitate. So any one of those 2 would get your marks there. Okay, you have to have the word heat and the actual colour that it goes. Part C. The student was asked to prepare a small quantity of ethene for the preparation and collection of ethene. Indicate clearly on your diagram the location of the ethanol, the catalyst, the heat source, and the ethene produced. And I think we're all okay with this. So this is my sideways test tube. This is my cotton wool. And that's soaked in ethanol. Okay, we then have our aluminium oxide, and directly underneath that aluminium oxide we have our Bunsen burner. Okay, and then it is collected over water. Okay, so that's my test tube here, and then my beehive shelf in a trough of water, and then my ethene is collected here. Okay, so that's my that is my diagram. Just here you're asked which one's the catalyst, so make sure that's labelled. That's your aluminium oxide, and the heat source we have, and the ethene is also labelled there, so we've answered those. Identify the catalyst. Okay, so and its appearance at the beginning. So again, I think we're all pretty okay on this. So catalyst, aluminium oxide, and it appears as a white powder. Okay, explain why a risk of hot glass for shattering is associated. So that is because of suckback. Okay, so remember, my solids, liquids, gases all expand when heated. So when they expand, they're going to end up going back here into the tube to fill the vacuum that's being created, causing this to crack. And how would I prevent this? We remove the delivery tubing. Before removing the heat. And finally then, we are asked a student prepared ethene starting with 2.9 centimeters cubed of ethanol. Calculate the volume of ethene gas. And we've looked at that already. That IV part is in your stoichiometry. Okay, so everyone should have that. If you don't, come back to me and I'll have a look at it with you. Okay.